Welcome to this explainer. Today, we're literally unlocking the cheat codes for your next networking exam or technical interview. We are going to completely demystify the TCP/IP architecture and break down exactly how the internet functions under the hood.
I mean, we all use the web constantly, right? But have you ever stopped to wonder how your data actually travels from your specific device all the way to a server somewhere out in the real world? It honestly feels like magic sometimes, but there's actually a highly structured, super implementable system making the whole shebang happen behind the scenes.
So here's our roadmap for today. First, theory versus practical reality. Second, the TCP/IP architecture. Third, exploring the protocol layers. Fourth, the data's journey. And finally, number 5, connecting the network.
Let's just jump right in with Section 1, Theory versus Practical Reality.
The contrast between these two is honestly fascinating. On one side, you have the OSI model, which provides this brilliant 7-layer theoretical framework developed by the ISO. It's a foundational model, and it's fantastic for learning the pure theory of networking. But on the other side, you've got the TCP/IP protocol suite. This is the gritty, implementable reality. It was created by ARPANET and heavily funded by DARPA, the US Defense Agency, and it's the actual architecture running the internet today. Because TCP/IP is a fully practical approach with absolutely zero time wasted on pure theoretical documentation, it became the undeniable champion of real-world internet communication. When you go with a practical approach, you don't just draft documents, you build systems that actually work.
Moving right along to Section 2, the TCP/IP architecture. Now, depending on which textbook your university happens to use, maybe it's for Roseanne or maybe it's Tannenbaum, you might actually see the TCP/IP stack represented a little bit differently. The major difference really just boils down to the very bottom of the stack. It's all about whether that bottom layer is combined into a single unified network access layer or if it's split out into separate data link and physical layers. Notice, though, the top 3 layers, application, transport, and internet, they remain exactly the same in both versions.
But here is the crucial point for you. In actual practice, the 4-layer architecture is significantly more important. Having a really solid, working grasp of this 4-layer model is absolutely essential for passing your exams and building a true foundational understanding of networking.
All right, let's break this down in Section 3, Exploring the Protocol Layers.
Starting at the very top, we have the application layer. This layer handles process-to-process delivery, synchronizes different encoding systems, manages your encryption and decryption, and maintains network sessions. This is exactly where the user sits. You're generating data using applications and protocols you probably use every single day. SMTP when you send an email, FTP to transfer files, or Telnet for remote login.
Dropping down one level, the transport layer takes over, and this one is entirely responsible for host-to-host delivery. This is where the communication gets set up to be either connection-oriented or connectionless, utilizing major protocols like TCP, UDP, and STP.
Next up is the internet layer, which takes care of source-to-destination routing. Critically, this is where the IP addresses actually get slapped directly onto the header. We're talking about the fundamental routing protocols here, things like IPv4 and IPv6, along with IGMP and ICMP.
And finally, right at the base, the network access layer manages the physical node-to-node transfer within your local network. This layer handles the MAC protocols, error control, and flow control to safely and reliably move the data from one specific machine to the next.
Okay, Section 4, the data's journey.
Let's actually track a single message top-down. A user generates data at the application layer. As it moves down to the transport, then the internet, and finally the network access layer, a brand new header is added at each and every step. It acts almost like a Matryoshka doll getting wrapped around the data. Because it's a stack architecture, this whole thing operates on a strict last-in, first-out basis.
Look, if you want to totally ace your technical interviews, you absolutely must know the exact terminology used for the information at each stage. At the top application layer, the information unit generated by the user is simply called data.
Once that data drops down a level and gets its host-to-host packaging at the transport layer, it actually changes names. We now refer to it as a segment.
Then, as it hits the internet layer and gets that all-important IP address header for source-to-destination routing, the segment officially transforms into a packet. And finally, when it's fully prepped with error control for local transmission down at the network access layer, it becomes known as a frame. So definitely remember that flow: data, segment, packet, frame.
Let's wrap things up with Section 5,
connecting the network.
Here's a really interesting quirk. Intermediary network routers actually don't process the entire stack. They only ever utilize the bottom two layers, network access and internet, to move the packet along. The router receives the frame at the network access layer, processes it up to the internet layer just to read the IP address, and then sends it to the next node. It literally just repeats this until it hits the final receiver, which then unpacks the data all the way back up all 4 layers to the user.
And the true beauty of the TCP IP stack is just how incredibly flexible it is. I mean, it seamlessly supports both centralized client-server setups, where clients are sending requests to a central server authority, and decentralized, mutually connected peer-to-peer data transfers operating in a fully distributed way.
So if you take nothing else away today, remember this. Whenever you are discussing real, implementable internet communication and how the modern web actually functions in the real world, you are always talking about the TCP/IP model. Period.
TCP/IP really is the practical engine of our modern world. But it does leave us wondering, as our networks continue to evolve and become more and more distributed, will this DARPA-funded model stay the undisputed bedrock of the internet forever? Or is there a new, practical model waiting in the wings? Thank you so much for joining me on this explainer. Keep learning, keep questioning, and I'll catch you next time.